It began almost silently, not with a rocket's thunder, but with a whisper from the moon. In early 2025, a transmission slipped through deep space networks, carrying data from a region that, until now, had been little more than shadow and speculation. The far side of the lunar South Pole. China's Chang'e 7 mission had just awakened, and what it revealed was more than a triumph of engineering. It was a statement. A quiet, strategic move in the most contested frontier humanity has ever entered. I remember the first images, streams of pale light reflecting off jagged craters, a terrain fractured by billions of years of cosmic bombardment. But beneath that beauty, there was purpose. Chang'e 7 wasn't sent just to observe. It was sent to claim understanding, to explore water deposits hidden in perpetually dark craters, and to establish, for the first time, a sustained robotic presence that could pave the way for a permanent lunar base. The mission's architecture itself is astonishing. A relay satellite orbiting the moon, a lander, a rover, and a mini flying probe capable of dipping into the eternal shadows where sunlight has never touched. Every part of it was designed for independence, precision, and silence. The kind of technological maturity that doesn't seek applause, only results. And as those first results began to reach Earth, traces of frozen hydrogen, whispers of oxygen-bearing minerals, a deeper realization began to take hold among scientists and strategists alike. This mission isn't just about exploration, it's about who defines the future of space itself. When Chang'e 7 touched down near the rim of Shackleton Crater, every detail of its descent was monitored not only by Chinese ground stations, but by telescopes and listening arrays around the world. The South Polar region, long thought to be a graveyard of frozen shadows, was suddenly alive with signals, telemetry, and a subtle kind of tension. This wasn't just another scientific mission, it was the opening move in a new era of lunar strategy. The far side of the moon, invisible from Earth, had always felt unreachable. Its darkness made it both mysterious and politically neutral. No nation could claim it. No telescope could easily peer into it. But Chang'e 7 changed that. By using the Kuekiao 2 relay satellite positioned in a stable orbit beyond the moon, China achieved what few believed possible: continuous communication from a region that has never seen Earth's face. That single link transformed an unreachable landscape into a navigable frontier. In the mission's first week, the rover's spectrometer began detecting small concentrations of hydroxyl molecules in the regolith, a subtle signature suggesting the presence of water bound within the minerals themselves. Even more intriguing were the readings from the flying probe, which glided just above the crater floor in total darkness. Its instruments recorded temperature fluctuations consistent with exposed volatiles and faint traces of hydrogen that could indicate buried ice pockets mere inches beneath the dust. This was confirmation that what orbital sensors had hinted for decades might actually be true, that the moon's poles are not barren, but reservoirs of frozen potential. Water, in the language of space exploration, means everything. Oxygen to breathe, hydrogen to fuel rockets, and the possibility of sustaining human life without constant resupply from Earth. But the magnitude of this discovery was matched only by its implications, because whoever learns to extract and use that lunar water first will hold the key to deeper space. It is no exaggeration to say that control over the moon's south pole could one day determine who reaches Mars, who builds orbital refueling stations, and who defines the economics of the entire cislunar space. NASA, ESA, and private companies were watching closely. Each image transmitted from Chang'e 7 wasn't just a scientific milestone, it was a strategic signal, a demonstration that the boundaries of exploration and power were merging. And then, just as the global excitement began to settle, a series of readings arrived that didn't quite fit any model, data so strange that even seasoned scientists hesitated to interpret them. Something in the crater was behaving differently than expected, something the instruments couldn't easily explain. The anomaly appeared in the thermal readings first, a patch of terrain near the crater's interior that seemed to retain heat far longer than it should. At temperatures hovering around 380 degrees Celsius, nothing there should hold warmth for more than a few seconds. Yet for several lunar days, sensors aboard Chang'e 7 recorded a persistent signal, pulsing faintly against the background cold. At first, engineers suspected a calibration error. Cosmic rays, instrument drift, perhaps even interference from the probe's descent thrusters. But cross-checks with Kuekiao 2's infrared mapping system confirmed it. Something below the surface was trapping heat. It wasn't a large area, perhaps 40 feet across, but it was enough to spark a chain reaction of theories. The simplest explanation pointed to volatile materials, possibly frozen carbon dioxide or ammonia mixed with metal-rich regolith that absorbs and releases heat differently. Others speculated about recent micro-impacts, exposing fresher layers of lunar soil. Yet a quieter faction inside the mission team began considering something far more consequential: subsurface cavities. Hollow zones where ancient lava flows may have carved tunnels beneath the South Pole, sealed by time, preserving pockets of primordial gas. If true, these could be natural habitats for future human explorers, protected from radiation, stable in temperature, and potentially connected to water-bearing strata. China's mission hadn't just stumbled upon a scientific curiosity, it might have found the blueprint for a lunar base. As images streamed back, they revealed an unexpected textural shift. The dust near the heat signature was finer, almost metallic in reflection, suggesting mineral segregation. Instruments detected elevated concentrations of titanium and rare earth elements, the kind essential for advanced electronics and clean energy technology. Suddenly, the discovery carried a dual weight: scientific wonder and economic opportunity. Global agencies took notice. NASA's Artemis planners reviewed orbital maps to cross-reference the site. Japan's Selene 2 mission team began adjusting its polar survey parameters. Even private space companies started analyzing whether future robotic miners could operate in such extreme light conditions. The moon's south pole was becoming a map of intentions, a quiet race drawn not with flags, but with data points. But as the heat anomaly persisted, and deep spectral scans revealed patterns no one had anticipated, one question began to haunt researchers in both Beijing and Houston. Were these thermal fluctuations natural, or evidence of ongoing, unseen processes beneath the lunar crust? The truth, it seemed, lay buried under miles of silent dust, waiting for someone bold enough to dig deeper. When the data from the heat anomaly reached the Beijing Aerospace Control Center, it triggered an internal review that went far beyond the scope of routine analysis. The lunar South Pole wasn't supposed to behave like this. It was meant to be predictable, a land of frozen stability, locked in eternal shadow. Yet here was proof of energy fluxes and mineral segregation that didn't fit any model of thermal equilibrium. The moon, long thought geologically dead, was whispering signs of motion. To verify the findings, the Chang'e 7 team deployed a secondary experiment, the Micro-Hopper probe. Barely the size of a backpack, it was designed to leap short distances across the terrain, scanning temperature gradients and magnetic field variations. As it descended into the shadowed crater, its cameras caught something no one expected: thin wisps of dust rising, illuminated only by the glow of its infrared sensors. On the moon, with almost no atmosphere, dust doesn't rise on its own. It clings, it settles, it stays, unless something below is stirring. When the magnetic readings came through, the patterns were erratic, fluctuating fields that hinted at trapped currents beneath the regolith. The moon's magnetism has long been a faint echo of its past, but these variations suggested residual energy, possibly from metallic inclusions shifting under thermal stress, or, as one geophysicist cautiously proposed, from pockets of electrically charged gas escaping from within. The implications were staggering. If active outgassing still occurs in the polar regions, it means the moon isn't completely inert. It's still alive in a slow geological sense, a body that remembers its volcanic youth, exhaling once in a while through fissures sealed for billions of years. That would change how we understand not just lunar evolution, but planetary formation itself. The data spread quickly through international channels. Western observatories began to confirm subtle electromagnetic echoes corresponding to the same coordinates. Some even speculated that these emissions could interfere with future radio telescopes planned for the far side. The discovery, meant to unite the scientific world, was quietly reshaping diplomatic postures. Suddenly, the moon wasn't just a destination. It was an asset, one whose secrets could redefine energy, materials, and technology on Earth. China's mission had reached beyond exploration. It had touched a new domain of influence. And as the probe's instruments continued to record faint seismic tremors deep below the surface, an unsettling realization began to surface among those studying the data. This was no isolated anomaly. Something beneath the lunar crust seemed to be awakening. By mid-2025, the Chang'e 7 team had accumulated months of seismic and electromagnetic data, and the patterns emerging were impossible to ignore. Small tremors, barely detectable at first, showed rhythmic intervals like the moon was breathing. Each pulse seemed to coincide with solar heating cycles, but the amplitude was increasing. Something within the crust appeared to be expanding and contracting with a kind of internal rhythm, suggesting stored gases or even molten material beneath solid rock layers. This was supposed to be impossible. The moon's volcanic activity was thought to have ended over 1 billion years ago. Yet the data told a different story. One of residual heat trapped deep underground, perhaps concentrated near the poles where temperature extremes create intense mechanical stress. Chinese scientists began cross-referencing these readings with data from NASA's Lunar Reconnaissance Orbiter, and astonishingly, faint correlations began to appear. The same coordinates that showed thermal anomalies also matched regions of slight gravitational irregularity detected years earlier, but never explained. The idea that the moon still possessed internal dynamics challenged decades of assumptions. If confirmed, it could mean that the moon is not a passive relic, but a dynamic system, one that might still be evolving. And that revelation carried enormous significance, not only for science, but for strategy. A body with active subsurface processes could alter how mining, construction, or long-term habitation must be planned. In internal reports, China's space agency began referring to these zones as energy-active sites. They outlined potential uses, from geothermal harvesting to localized radiation shielding using electromagnetic differentials. It was a vision of self-sustaining lunar infrastructure, powered by the moon itself. Meanwhile, other nations took notice. The Artemis program accelerated plans for its own polar landers. Private aerospace companies began mapping potential routes that intersected these same geophysical hotspots. The moon, once seen as neutral ground, was rapidly becoming a chessboard, each crater a possible strategic foothold. Yet amid the geopolitical maneuvering, a deeper question began to echo among scientists worldwide. If the moon still breathes, what is it trying to tell us? Could its hidden motion be a clue to the early solar system's formation? Or a warning of structural instability we don't yet understand? No one could say for certain. But as one Chinese geologist quietly wrote in her mission log that July, the moon may be older than life on Earth, yet somehow it feels alive enough to listen. In August 2025, a new signal joined the conversation, not from the surface, but from deep beneath it. Chang'e 7's seismometer network, still active near Shackleton's Rim, detected a series of vibrations unlike the microquakes that typically ripple through the moon. These were sharper, more coherent, repeating every few hours with uncanny precision. The pattern drew immediate attention, especially because each pulse corresponded to faint gas emissions detected moments later by the probe's spectrometer. What began as a mystery of heat had evolved into the discovery of an active subsurface venting cycle, the first ever recorded on the moon's south pole. Scientists theorized that ancient volcanic conduits, long sealed by time, were briefly reopening as thermal gradients deep below fluctuated. With the polar region's extreme cold and long shadows, even a minor surge of trapped gas could erupt with measurable force. When the composition of the emissions was analyzed, the results deepened the intrigue. Carbon monoxide, traces of methane, and a small but consistent presence of helium-3, the rare isotope long regarded as a potential future fusion fuel. The finding was both scientific gold and geopolitical dynamite. If helium-3 existed in extractable quantities near these fissures, whoever mastered its collection could reshape the global energy equation for centuries. Internationally, reactions were immediate. The US, Japan, and India accelerated their polar mapping missions. Private consortia began designing robotic miners capable of operating in perpetual shadow. For China, this was validation, proof that its decade-long lunar strategy had reached a turning point. The Chang'e program was no longer just about exploration. It was about resource sovereignty on an interplanetary scale. Still, not everyone shared the enthusiasm. Planetary scientists warned that extracting volatile gases without understanding the moon's internal balance could destabilize its fragile crust. If the moon is venting, one ESA researcher cautioned, it may be relieving pressure that's been building for eons. Interfering with that system could have unpredictable consequences. Within weeks, seismic activity around the region intensified. Subtle tremors began to cluster near older crater rims, and electromagnetic sensors picked up low-frequency fluctuations spreading across the polar plateau. Some theorized it was the sun's radiation interacting with buried minerals. Others whispered a darker thought, that human interference had already begun to awaken something dormant beneath the lunar crust. Whatever the cause, the signals kept coming, methodical and haunting, as if the moon itself were sending a coded message across the void. By September 2025, the moon's whispers had grown too loud to ignore. The Chang'e 7 lander, though battered by months of dust exposure and temperature extremes, continued transmitting seismic and magnetic data with eerie regularity. Each new cycle of venting aligned with rising solar activity, a delicate dance between radiation, regolith, and something hidden beneath. The more sunlight reached the crater's edge, the more active the subsurface signals became, as if the moon were responding to the sun's heartbeat. At the Chinese Academy of Sciences, a multidisciplinary task force was assembled: geologists, plasma physicists, and systems engineers working around the clock to model the phenomenon. Their simulations revealed something extraordinary. Beneath the Shackleton region might lie a vast pocket of low-density material, possibly a cavern formed by an ancient lava flow that never fully collapsed. Its porous structure could trap volatiles and slowly release them as solar heating altered the crust's tension. In essence, the moon was exhaling, a slow geological respiration stretching across millennia. But the timing of its resurgence, coinciding with human exploration, carried an uncanny symbolism. Humanity had returned to the moon, and the moon had stirred in response. The implications rippled through the international community. For engineers, this meant potential access to stable underground habitats. For politicians, it meant leverage. And for scientists, it hinted at something poetic, that our closest celestial companion might still be evolving alongside us. Yet the data didn't stop there. Instruments aboard Queqiao 2 began detecting weak radio emissions localized to the same coordinates. They weren't artificial. Their frequencies matched natural plasma oscillations. Still, their precision was unsettling. A rhythmic hum, low and continuous, as if echoing the same pulse the seismometers felt below. NASA's Lunar Gateway Station confirmed the anomaly from orbit, adding a layer of international curiosity and unease. The moon wasn't supposed to speak, yet now it resonated with a sound that felt deliberate in its steadiness. As the global scientific community prepared a joint statement, a new transmission came from Chang'e 7, incomplete, fragmented, but carrying one unmistakable signature: a sudden, sharp spike in helium-3 concentration, followed by silence. Then the feed went dark. All telemetry ceased. For the first time since its landing, the far side of the moon was truly silent again. For days, there was nothing, only the quiet hiss of cosmic background noise. Then, slowly, fragments of Chang'e 7's final transmission began to reappear, relayed through Queqiao 2's buffer memory. The data was incomplete, corrupted by radiation bursts, but what survived told a story both humbling and profound. The spike in helium-3 had not been random. It was followed by a brief surge of thermal energy spreading across several miles of the crater floor. A release, not an explosion. The moon had simply breathed out, one last exhalation after untold ages of silence. When Chinese engineers confirmed the lander's systems had powered down for good, there was no sense of loss, only awe. The mission had done what no human or machine had achieved before. It had proven that the moon still changes, still interacts, still responds. It isn't a frozen relic hanging above us. It's a living memory of planetary evolution, and perhaps a mirror for our own restless drive to expand. In the aftermath, the world's spacefaring nations quietly shifted course. Plans for extraction turned toward preservation. The idea that humanity might coexist with the moon's natural rhythms, not dominate them, began to take root. And as we look back at that moment, one truth remains clear. China's mission didn't just redefine lunar exploration. It reminded us that every act of discovery carries a choice: to exploit or to understand. Which path we take next will define not just our future in space, but what kind of species we choose to become.